So first of all, I'd like to greet all participants of this school, and I'd like to say that we have been organizing this school for 6 years, and this school is number 6. And the second year in a row, we hold this summer school on engineering, computing, and in nuclear technology in online mode. And some people say that there are some advantages and maybe disadvantages of having this school online. But I think the best thing in this online format that a lot of people from all over the world can join us, and a lot of top speakers can also give their lectures in this format. I think it's the positive that we can take from this pandemic, if you want one thing. And the presentation which I would like to give you about one of the organizers of this school, the National Research Nuclear University MIFI, was prepared by me and Professor Georgy Tikhamirov, but unfortunately he didn't manage to participate today for some reasons. And on behalf of him and all the organizing committee of this school, I'd like to share some slides about the National Research Nuclear University, MIFI, and the Institute of Nuclear Physics and Engineering, which is the major institution in our university which is specializing in nuclear physics and nuclear technologies. Let me start with a very short history, a brief history of our university that was established in 1942 in response to the American Manhattan Project, which was aimed to create the first atomic bomb, the so-called the Soviet atomic project, and 6 Nobel Prize laureates significantly contributed to the creation of our university. You can see them on the slide, and we really take pride in this fact. MEFI is a network university that consists of 18 regional branches, all of them scattered all around the Russian Federation, mostly near to cities where there are Rosatom State Corporation facilities, for example, nuclear power plants or nuclear reprocessing plants are located. And the main campus is located in Moscow, where all my colleagues and I work. And the second one is located in Obninsk, which is about 100 kilometers from Moscow in Kaluga region. And you can see some transmission of our university from Moscow Mechanics Institute of Ammunition, which was created in 1942, to Moscow Engineering Physics Institute, to National Research Nuclear University, MIFI, and that's the name for our university, official name for our university now. Also, I would like to add that we have one international branch in the Republic of Uzbekistan, which was opened 3 years ago in order to prepare staff for the future nuclear power plant in this country, which is under construction now by the Rosatom State Corporation. Here you can see our educational programs, major programs. There are lots of them. Of course, we are the best, one of the best universities in the world in the field of nuclear technologies and such fields as nuclear physics and technologies, material science, nuclear power engineering, and thermal physics. But as well, we specialize in other fields like, for example, laser technologies, electronics, nanoelectronics, photonics, and optical informatics, software, of course, in software engineering, information security, cybersecurity, chemistry, and even in some other fields, for example, economics, business informatics, and even international relations. And if we talk about our international students, as we are a global university, we have students from 79 countries now. In total, we have about 20,000 students, and about 26% of them are international students from, as I have already mentioned, 79 countries. And these countries are the countries of the Rosatom State Corporation partner countries. For example, we have a lot of students from such countries like, for example, Turkey, Egypt, Bangladesh, where their nuclear power plants are under construction right now by the Rosatom State Corporation. In total, we have about 60 majors for master degree, bachelor degree, and PhD degree in 2 languages. So you can study in Russian or in English languages at our university. And of course, I'd like to highlight that we are a member of several international educational networks, for example, as ENAN, STARNET, and ANANT. And we collaborate intensively with, for example, International Atomic Agency in Vienna and the Nuclear Energy Agency in Paris. And our students on a regular basis visit these organizations as interns, for example. I'd like to add that MEFI is not the only university in Russia which prepares staff for the Rosatom State Corporation. We have 18 universities which are combined in so-called Rosatom consortium of core universities, but we hold a position of the leader of this consortium, and of course we are the leading university in terms of preparing staff for the nuclear industry, not only in the Russian Federation, but all over the world. A little bit about rankings. We sit pretty comfortably in world rankings, for example, in THE ranking and QS rankings, international rankings, one of the most famous ranking system. And we are in top 500 in global rankings, and in subject rankings, for example, in physics and astronomy and natural science, we sit in top 100 or top 200. It depends on the ranking. A couple of words about the general structure of our university. It consists of 5 institutes. The first one is called the Institute of Nuclear Physics and Engineering. As I have already said, my colleagues and I work there, and we specialize in atomic power industry, development of novel nuclear system and materials, new power technologies, and of course fundamental research in physics, for example, particle physics and cosmology. The second university is called the Institute for Laser and Plasma Technologies, which specializes in quantum and precise laser measurements, radiation and beam technologies, and industrial laser technologies. Also, we have a PhysBio Institute, Institute for Physics and Engineering and Biomedicine, which specializes in nanotechnologies and nuclear medicine, and in a new field of medicine that is called nanotheranostics. One more institute is the Institute of Nanoengineering and Electronics, Spectronics and Photonics, which has major specialization in electronics and quantum information technologies. And of course, the second largest institute is the Institute of Cyber Intelligence System that specializes in cybersecurity, artificial intelligence, and other fields of information technology, including protection of computer systems. Let me tell you a little bit more about the Institute of Nuclear Physics and Engineering, as this is the key institute in the structure of our university. And it can be divided into 3 major parts. The first one is the so-called Nuclear Power Center, which specializes in all fields related to the modern atomic energy. The second one is center is the nuclear systems and materials. Center specializes in production of novel materials, not only for the nuclear industry, but other fields, for example, aerospace industry. And the third part of our institute is the Fundamental Research and Particle Physics Center, which is specializing in solving fundamental problems, for example, experiments and CERN at the Large Hadron Collider, and looking, for example, for dark matter. Nuclear energy and technologies at our university are represented mainly by these fields, which you can see on the slide, for example, research on radiation transport and ecology and nuclear facilities. Of course, research on neutron physical processing, modeling of physical processes that happen in the nuclear reactor core. And of course, this school is a topic of this research, and I hope the participants will get new knowledge and some practical skills after visiting, attending our lectures and practical exercises. Lots of work we pay to technologies. Of course, nuclear fuel cycle, which is a future of the nuclear industry. Also, perspective methods of energy transfer, or for example, utilizing solar energy.
I think it takes 1 minute. Something wrong with Alexander.
Virtual reality, nuclear energy, and I think we have a talk today by our PhD student, Vlad Romanenko, who will tell you in more detail about virtual reality, nuclear energy, and what our university is doing in this field. Some words about particle physics experiments. We participate in more than 30 international collaborations, such as ALICE Atlas or CMS at Large Hadron Collider in CERN in Switzerland, and for example, in a new collider called NICA that is under construction in the Russian Federation now, and some other experiments in high energy physics and cosmophysics. Also, I'd like to add that we have quite sophisticated infrastructure right on the campus. We have, for example, experimental facility NEVAD, which is looking for muons from the cosmic rays, is trying to solve some fundamental problems in these fields. And of course, all our students participate in a lot of activities and participate in international experiments. And our contribution to these experiments lay in, for example, in development of new detectors, new facilities, and of course, R&D projects and simulation and data analysis of experimental data. And we pay a lot of attention to our practice and training, and all our international students who study in MEFI have their practice, which is basically 2 weeks long, and is performed at our so-called resource centers, which are located in our our branches in the cities of Volgodonsk, Novovoronezh, and Obninsk. And near these cities are located some facilities, nuclear facilities operated by the Rosatom State Corporation. And our students can visit these facilities and participate in some activities related to their future profession and their career. And we have a lot of training facilities, training labs during these practices, and of course a research reactor, which is located not only in Moscow but also in Obninsk, called VVRC, with a total power of 15 megawatts. I think I can stop now, and thank you for your attention. And also I would like to wish for all participants a fruitful summer school. And I think after completing this school, we will get a lot of knowledge in nuclear simulation and a lot of practical experience. Thank you for your attention again.
So, hello everyone. Again, my name is Vladislav Romanenko, and I'm a PhD student at MEFI University. And I'm here to represent their laboratory located in MEFI. So, in case you don't know what is virtual reality, that's simple. You just put the special helmet on your head and you are inside 3D. So you are in virtual reality, you can interact with this reality. And in case of augmented reality, that's a little bit different. This is a combination of reality and virtual things. So we study both virtual reality and augmented reality in MEFI. And if you will look on the typical VR project scheme, for AR, it would be the same for us. It is quite difficult. So the heart of our projects is the game engine. We use Unreal 4, which is free and simple to start to use. But there are many game engines which could be used also in science applications. So because of VR is all about the 3D environment, we need to have geometrical data, and we could gain this geometry data from the CAD models, from the polygonal models, from the photogrammetry and 3D scanning. It's quite difficult sometimes to process this model because you need to optimize them, you need to unwrap them, to texturize them, to animate them, and then just you import it inside your engine. And as soon as our lab, which was established in 2018, all members of our lab are specialists in nuclear reactor physics. We are concentrated in integration of the physics inside VR. So that's why we use simulation data and tools, and we're trying to import the physical processes inside VR. So it basically we have just two approaches to integrate our physical solutions into the virtual reality. We could use the data from the calculations, and we could use directly the simulation codes and algorithms. And all these things we integrate into the engine using the special engine functionality. Also program a lot, so VR is quite difficult and you need lots of skills. And in case of virtual reality, we started to think what to begin from, where from. And in MEFI, we have different nuclear experimental facilities, such as the upper one, uranium graphite subcritical assembly, and the lower one, uranium water subcritical assemblies. So we started our VR lab from doing the laboratory work. We wanted to reproduce the full sequence of the laboratory work we held on these experimental facilities. And the laboratory works on these facilities associated with the calculation of material parameters of these facilities by measuring the neutron flux axial distribution. And also in 2008, 9, someone from MIFI developed the desktop application. So we already had the desktop application, and we thought, why not to try VR? And this is how it looks like for now inside the virtual reality. It has some features, of course, our project, because inside this two labs, you could interact with the objects, you could do all the things you could do in the real laboratory work. We have built-in model for accumulation of dose, radiation dose rate. We have the visualization of the neutron flux distribution and radiation dose rate distribution, and other stuff. And I will show you just a short video. Here you could see the hole with the assemblies. Here is this uranium graphite subcritical assemblies. And this is the procedure how we put the neutron detector inside the facility. Here the counter device to calculate the neutron flux, to measure it. Here's the procedure to change the step of the fuel pins. Here's the neutron flux visualization and the radiation dose rate visualization inside the building. And here is radiation dose rate visualization and neutron flux visualization in the uranium graphite subcritical assembly. We also have a few more different projects. We cooperated with the thermal hydraulic department in MIFI, and we created this thermal hydraulic flow loop. We imported this model from the KD. And then we thought about how to reproduce the distributions we obtain in this stand in real time. And we developed the procedure to colorize the textures of the stand to somehow represent the distributions of the different parameters, and we are able to make it real time actually. So we think about also the control of thermal hydraulic facility from the virtual reality, but it's quite difficult. It would take some time. We also had the cooperation with the nuclear physics department, and we tried to visualize the extensive air showers. Extensive air shower, it's particle showers that created by the cosmic high energy particles, and you could see this visualization right here. This visualizations was created by using the data obtained from Corsica and Gen4 programs. And inside VR, you could filter particles by the energy and type and so on. We also deal with the photogrammetry and laser scanning because it's quite useful technology for the future, because it allows us to get the 3D model of some real objects and put it into VR. It could be also used in nuclear field, like for example, you put the robot inside the Fukushima power plant, and then it takes pictures or photos, or it scans by laser the inside environment, and then you got the 3D model. You could put it in VR, and you could see, you could look onto the environment and find something for it's that important for you. And There are also a few more applications of the laser scanning and photogrammetry, such as we could integrate this technology into beam models. We could use directly point clouds in VR or meshes. We could use the meshes from the laser scanning and photogrammetry and optimize them. For example, here on the right, we see the green one is a model we obtained from the photogrammetry. The right model, simple, is the VR model. And by using the different techniques like normal maps and texture maps, we could create this below on the right model. It looks the same with the model we obtained in photogrammetry, but it's hugely optimized. And VR is always about optimization because you need 90 frames per second, so you have to deal with it. And also we are studying augmented reality. So we think it's important because as soon as we will obtain the devices which will be cheap and easy to use, it seems like the way we interact with our electronic devices will somehow change. That's why we study it, also in the field of nuclear. And we have two projects for now. It's the same thermohydraulic flow loop digital twin. It allows us to place this loop actually where we want and to look at the condition of the state. So for example, on the video, you could see the we have tried just to set up the randomized data and see if our phone could produce this dynamic calculations, and it's actually cool. And we are also working on the radiation dose rate, 3D real-time distributions visualization. That's the project which is going on, and I have nothing to show to you by the pictures. Okay, and as a conclusion, I would like to say that we've demonstrated you all our VR AR projects, and we are working now on the many different projects. For example, we are started now, we almost finished it, the critical facility in VR, where we integrated also the point kinetics algorithms, so we could do some stuff and see the graphs, the changes in real time. We also deal with the BFS facility. We want to implement there the simulation code to try to use the simulation code from inside of VR. We also want to continue the work with AR, and it seems like we will have also the project with our MIFI ERT reactor, and we could also try to use the complex approach because we have a lot of experience already, the complex approach of using the photogrammetry, VR, AR, and multi-physics technologies in virtual reality. So thank you for your attention, and if you're interested in, we have the social media pages, and we also have the website you could check on. And I want to also wish you the good luck.
So, as mentioned above, this is the 6th year when we organize the school, and this is the 2nd year when it is in a remote online format. ECINT School is a certificate course aiming to provide specialized education and training on mathematical modeling of physical process. And the founder of the school is a full professor, Georgi Tikhamirov, and he couldn't attend the school opening today, but you will see him, I think, maybe school closing. And since 2018, the school is organized jointly with the Western University of Applied Science. And the main goals of ECINT school are introduce modern codes that are used in the nuclear and other industries, introduce introduce the issue of multi-physics modeling, getting insights from the world's best specialists, and establishing international cooperation and knowledge exchange. Every year, the number of applications and participants is growing rapidly. This year, 162 applications from 34 countries were submitted. Since we have practical sessions, we had to select only 60 students, young professionals, and postgraduates from nuclear field from 29 countries for full participation. However, during the first 4 days, there is a plenary session to which everyone can join. And there is a very exciting list of speakers. Today, you are going to hear from first our keynote speakers, Dr. Konstantin Mikityuk is Advanced Nuclear System Group Leader at Paul Scherrer Institute. Actually, Konstantin is graduated from MIFI, and now Konstantin is a representative of Switzerland in Generation for International Forum Expert Groups, and he is co-chair of DIF Education and Training Task Force. And today, Konstantin will give us a lecture on Generation 4 reactors. The next keynote speaker is Dr. Hiroki Takizawa, who is a researcher at the Laboratory for the Zero Carbon Energy, Tokyo Institute of Technology. And together with colleagues, Hiroki works on improvement to critical safety technology for Fukushima Daiichi nuclear power station decommissioning. Hiroki will present applications of Monte Carlo neutron transfer calculations to space-dependent kinetics. And the next presenter for today is Professor Igor Piero. He is a full professor at University of Ontario. Dr. Igor is an editor in several very respected journals, and today he will have a keynote lecture about the nuclear power in the world. Tomorrow, we will listen to no less interesting lectures from Chirag Batra, nuclear engineer and nuclear power project officer at International Atomic Energy Agency. He is currently focusing on fast reactors and small modular reactors, working both on technological and economic aspects of development and deployment of advanced reactors. Next one is Dr. Jan Dufek, Associated Professor at Nuclear Engineering Division, also Director of Nuclear Engineering Master Program and KTH Royal Institute of Technology. And tomorrow he will present aspects of steady-state coupled Monte Carlo simulations. And also we'll hear a lecture from Professor Kostadin Ivanov. He is the head of Department of Nuclear Engineering at North Carolina State University. Kostadin is the chair of Working Party on Scientific Issues of Reactor Systems at the Nuclear Science Committee Nuclear Energy Agency. And tomorrow, Kostadin will present the lecture titled High to Low Model Information and Uncertainty Propagation in Nuclear Reactor Design and Safety Modeling and Simulation. On Wednesday, Professor Christophe de Mazière, lead of the DREAM Task Force at Charles University of Technology, will tell us about deterministic modeling of nuclear systems multiphysics. Also, Dr. Jan Perrin, scientific researcher from GRS, Germany, will present lecture about multiphysics core simulations from core mesh to high-resolution modeling. And also Dr. Manuel Alfiero, founder and CEO of Milano Multiphysics, will tell us about reactor modeling method as data analysis tools. And on the 1st July, Dr. Victoria Popsuyeva, Associated Professor at Western Nova University of Applied Science, is going to give us a short workshop, first a review of basics of fluid dynamics and fluid mechanics, and then numerical and computational methods in applied and theoretical hydrodynamics. And then we will listen to the introductory lecture about flow vision from technical support engineer of engineering company TESIS. Starting Friday, we will begin practical session where you will get acquainted with CFD code flow vision, Russian Monte Carlo code MCU, and simulation software StarCCM under the direction of engineers Natalia and Daniil from Thesis Company, Dr. Denis Shkarovsky from National Research Center Kurchatov Institute, also from Research Associated Sergei Anpilov from Lomonosov State University, and Professor Boris Balakin from Western Nova University of Applied Science. And I hope this will be very interesting and useful for you. So please, if you have questions, you will write me by email. And also we have a Google Disk. So about school, I think that's all.